Assalamu alaikum, dear students. In previous lecture we discussed the linear inequalities and their solutions. Now today we are going to discuss this exercise 6.1 to find the solution of linear inequalities or solve the linear inequalities for x. Now the first one is find the value of x such that 4x plus 3 less than 5x plus 7. Now by transferring this 5x variables from one side and constants on another, we get 4x minus 5 less than 7 minus 3, which implies that minus x is less than 4 or x is greater than minus 4. This means that the set of all real numbers which are greater than minus 4 satisfies the given equation, first given inequality, or simply we can say that the all real numbers greater than minus 4 satisfies this. Now the second one is 3 into x minus 1 less or equals to 2 into x minus 3. Here this inequality is slack inequality because here we have equality sign also. So by simple multiplication from both sides we get 3x minus 3 less or equals to 2x into, that is 2x, 2 into minus 3, that is minus 6. Now arranging these terms, it is 3x minus 2x less or equals to 3 minus 6, that is x less or equals to minus 3, which implies that all real numbers which are less or equals to minus 3 are the solutions of this inequality. Now the third one is x by 3 greater than x by 2 plus 1. Now shifting the terms, it is x by 3 minus x by 2 greater than 1. By cross multiplication in LHS we get 2x minus 3x upon 2 3s are 6 greater than 1, or minus x by 6 is greater than 1, or minus x greater than 6, because by cross multiplication, which implies that x is less than minus 6. So this means that set of all real numbers which are less than minus 6 satisfies the given inequality or is the solution set. Now the fourth one is 3 into x minus 2 upon 5 less or equals to 5 into 2 minus 3 up 2 minus x upon 3. Now by simple cross multiplication, it is 3 into 3, that is 9 into x minus 2 less or equals to 25 into 2 minus x. By multiplying, it is 9x minus 18 less or equals to 50 minus 25x, or 25x plus 9. By shifting minus to 25x to LHS, it is 25x plus 9x less or equals to 50 plus 18, which is 34x less or equals to 68, or x less or equals to 68 upon 34, which is 2. So this means that set of all real numbers which are less or equals to 2 satisfies this given inequality. Now in from these examples or from these questions, that the solution of these linear inequalities represents the set of real numbers, or simply the subset of real numbers. Now we can represent this subset on the number line, that is simply called as the solution of this linear inequality through graphically. That is representation of a solution on number line. Now if we consider an inequality 3x minus 2 less than 2x plus 1, that is 3x minus 2x less than 2 plus 1, which is x less than 3. So this means that set of all real numbers which are less than 3 is actually the solution set of this inequality. So on number line, if we consider the number line, so set of all real numbers which are less than 3 is actually this, marked with this colored. Now we have to exclude this 3. So this means that simply add 3, draw a circle and join this with this line. So this means that this hollow circle simply means that 3 is not included in this solution set. Like if we consider 2x minus 1 upon 4 greater or equals to 3x minus 2 upon 4 minus 2 minus x upon 5. So in RHS we simply multiply it by doing cross multiplication. It is 5 3s are 15x minus 10 minus 8 plus 4x upon 5 4s are 20, which is simply 19x minus 18 upon 20. By cross multiplication, it is 20 into 2, that is 40x minus 20 equals to, greater or equals to 76x minus 72, which implies that 72 minus 20 is greater or equals to 76x minus 40x, which is 52 greater or equals to 36x, or x less or equals to 1.4. So this means that set of all real numbers which are less or equals to 1.444 actually is the solution set of this linear inequality. And on number line we can represent this statement as, now here when we draw a number line, this 1.44 lies between 1 and 2, so this means that, and this 1.44 is included in this set, or it satisfies the given equality. So this means that we have to include this 1.44 in the solution set. Hence we have to consider all numbers, that is this up to this 1.44, and this here shaded dot, or simply the dot, represents or indicates that this 1.44 belongs to the solution set, or it simply satisfies the given inequality. So in this way you can solve these all such inequalities and represent the solutions on number line. Now we will consider this problem of, which is question number 21. Now the Ravi obtained 70 and 75 marks in first two unit tests. Find the minimum marks he should get in the third test to have an average at least 60 marks. So we have to find the minimum marks of which Ravi obtains, so as to maintain the average in three tests at least 60 marks. Let x be the marks obtained by Ravi in the third test, so that his average is maintained at least 60 marks in 3 unit test. At least means minimum. So this means that when we consider average of 3, which is 70 plus 75 plus x upon 3, which is the average of the marks obtained by Ravi in these 3 tests. Now this average should be at least 60. This means that it should be greater or equals to 60. Or after simplifying this equation, we simply get x greater or equals to 35. So this means that x greater or equals to 35. Thus Ravi must obtain a minimum of 35 marks to have an average of at least 60 marks. So in this way you can solve this very problem. Now another is, find all pairs of consecutive odd positive integers. We have to find odd positive integers, pair of all odd consecutive positive integers, both of which are smaller than 10, such that their sum is more than 11. Now let x be the smaller odd integer than its consecutive, or the next odd number is x plus 2. By the question, both are less than 10, which implies that x is less than 10 and x plus 2 is less than 10, because x and x plus 2 are the consecutive pair of odd integers, or simply the consecutive odd numbers, which implies that x less than 10 and x less than 8, because x plus 2 less than 10 implies x less than 10. So in both cases we get x less than 8. Also their sum is greater than 11, which implies that x is one odd and its consecutive odd is x plus 2. Their sum is greater than 11, which implies that x plus 2 is greater than 11, or x is greater than 2x is greater than 9, which implies that x is greater than 4.5. So this means that we have to consider, or we have to consider equation first and equation second. When we consider equation first and equation second, x less than 8 and x greater than 4.5, but x is odd integer, which implies that 4.5 is not integer. Now the next integer, or the nearest integer which is odd and which is greater than 4.5 is 5, 7. So 5 and 7 are the required odds which are greater than 4.5 and less than 8, which implies that when x is 5, its conjugative becomes 5 plus 2, that is 7. So 5 and 7 is one pair. Now when x is 7, which implies that 7 plus 2 is 9. So 7 and 9 is another pair. So these are the two pair of consecutive odd numbers, or required pair of consecutive odd numbers, which are less than 10 and their sum is less than greater than 11. So in this way we completed this exercise 6.1. Inshallah tomorrow we will discuss another exercise. So thank you.